Alright, so we're going to start looking at Chapter 2, which is all about describing the distribution of a variable. This should be a review of statistics that you've had previously, but if you don't quite remember, that's fine. We are going to go over it. So let's just start working through it. So our goal is, in any of this stuff, is we want to make data and be able to present it in a way that people will understand what's going on. And that's the biggest challenge whenever we're talking about data, is presenting it to an audience that may or may not understand the mathematical backgrounds behind it, may or may not care about the mathematical backgrounds behind it. They just want to know the key takeaway. And so the way that we're going to do things is we're going to use a lot of graphs, because a picture is really worth 1,000 words. Bar charts, pie charts, histograms, scatter plots, and time series graphs. We're going to talk about a lot of numerical summary measures in this class. Counts, percentage, averages, and measures of variability. And then tables of summary measurements, so totals, averages, counts. All of these grouped by category. So this is through the entire class. This is the kind of stuff that we're going to be learning to do and look at. So there are 4 steps in any data analysis. We have to recognize that a problem needs to be solved. That's step 1, realizing that you have a problem. Step 2, we're going to gather data to help us understand and model the problem, then we can solve it. We're going to analyze the data using tools that you're going to learn in this class. And this analysis is sometimes not just a one-step, it's you're doing it again and again and again. And then finally, you're going to act on this analysis by changing a policy, taking some kind of initiative, publishing a report, doing whatever you need to do. And so this is kind of the overall framework of the way data analysis works. Now, as we're talking about data analysis, we have some basic concepts that we need to understand. And so we're going to talk about populations and samples, data sets, variabilities and variables and observations, and types of data. And so that's what we're going to cover today. So the first one, and this is a really important distinction to make, is the difference between a population and a sample. Because this is going to come up a ton in this class, especially as we move on from this introductory material and start getting into probability distributions and whatnot. So the big difference is the population's everything. And typically, you're not able to query everything because there's just too many. If you had to do some population study in the United States and you're talking about 330 million people, you're not going to be able to individually talk to 330 million people. And so that's what you use, what's called a sample, which is a subset of the population. And as we'll go forward in this class, using some techniques, we should be able to take that sample of the population and project ideas onto the population as a whole. So once again, population's everything, sample's a small size within that population. So other definitions, we've got a data set. Now a data set is usually a rectangular array of data, which means that we have rows and columns. Variables will be in the columns, observations will be in the rows. So what's the difference? A variable, also called a field or an attribute, is a characteristic. It's something that you measure from your population. Height, weight, eye color, salary, just something that you're going to measure. So what is an observation? An observation is a list of the variables for a single member. So if we took our entire class and we put together height, gender, salary, eye color, hair color, that would be the variables, and an observation would be, so we looked at me, 6 foot tall, male, not enough, blonde, blue, that would be the observation for me. Now, as we look at that, you realize that we had a couple different kind of things in there. We had numbers, and then we had words. So there is a difference between the different data types, and so let's talk about that right now. So numeric data. Numeric data just means a number. It means that you can perform arithmetic on it. If it's not numeric, it's got to be categorical. And categorical is stuff that you can't have numbers on. So that would be like eye color, blue. You can't multiply blue by brown. It just doesn't work. So that would be categorical data. There is a third type of data that it's a little bit different. It's just a date variable. And because you can kind of do math on it, but it represents a date, so it's kind of a weird in its own thing. We treat it differently than numbers. And so from there, when we're looking at categorical variables, we do have two different kinds of categorical variables. The distinction isn't super important, but just to let you know anyway. So it can be ordinal, which means that there's a natural ordering of the possible categories. And if there is no natural order, it would just be called nominal, which means it's just kind of crazy and out there. So like an ordinal categorical variable is something like education level. There's a natural ordering because you can go from bachelor's to PhD. Other things, it's just nominal data because there is no ordering, like eye color. There is no natural ordering of eye color. Okay, so other kinds of data and other things is categorical variables can be coded numerically. And one of the things that we will learn in this class is what is called a dummy variable. And it's basically just coding a categorical variable 1, 0. So it's ones for, so if we were going to make a dummy variable for, we're looking at all the eye color, and we go, okay, well, blue, we're going to make a dummy variable called blue eyes. And so everyone that has blue eyes will code 1. Everybody that has a color other than blue would be coded 0. And so this, we are going to talk a lot about dummy variables as we get along in this class. We have what we call a binned variable. And that basically, it corresponds to a numerical variable that's been categorized into discrete categories. So it's basically, we can sit there and start dumping data into what we call bins, where we can do whole counts. And so that's something, if we were looking at salaries of baseball players, we could bin the salaries and go, okay, well, everybody that makes from 500,000 to 1 million, we can throw into one bin and count how many players are in that category. And so that's something else that we will take a look at as we go on. Other definitional stuff is, and this is an important distinction, especially when we talk about population densities and probabilities, is it a variable discrete or continuous? What's the difference? Discrete means it results from a count. We can count that. You can count the number of my kids. 1, 2, 3. There you're done. There is no 1.5 children. Not without some grisly slasher movie. But it's just something that we can sit there and count. A continuous variable is something that essentially you can have infinite amounts of increment steps. So height and weight are two big ones, because I am 6 foot tall. As I get older, I can shrink a little bit and be like 5 foot 11 inches and 5/16 or whatever. Or as my children grow every day, they can sit there and they can be 4'2" one day, and they'll be 4'2" and 1/4 the next day. There's infinite slices in between, so it's continuous. It just doesn't stop. We can look at what we call cross-sectional data, and so it's a data that's just basically the data on a cross-section of a population at a distinct point in time. And so we make our little data set and we just go, okay, well, I want to know what the height data for everybody is. Well, that's the cross-section. I can look at the entire height data for everybody, and most of the data that we end up looking at is cross-sectional. But we do deal with time series data, and that's just data collected over time. And so one of the examples that we'll do, we're actually like tracking crime statistics as a function of time. And so we're just looking at how these one specific individual crimes change as we go along. This is just typical time series data. We're looking at revenue per quarter as we go along. Okay, so let's talk about summarizing categorical variables. Because there's only a couple different ways, because categorical, there's no numbers. There's only a couple different ways that we can look at it, and it's all based on counting, because that's all we can do. So we can count the number of categories, we can give the categories names, and then we can count the number of observations in each category. And typically when you do that, you either give it in, this is just the number of the count, which is a raw count, or typically a lot of times you will look at percentages of totals. So we could do an informal thing in this class. We could look around and say, you know, who, I'd say smokes, but that's not really a big one anymore. We could say who in this class has a drink on Friday nights, and we can sit there and we would just go through, there's 20 or 30 of us, and we could go and count how many of us have a drink on Friday nights. And so let's say that out of the 30 students, let's say it's 10. So the raw count would be 10, and that's sometimes not that useful because you don't, okay, well, it's 10 out of 30. Okay, well, that gets a little bit more useful, and so that's about 30%. And what's nice about that is we can count them, we can display them graphically, and a lot of times you'll use a column chart or a pie chart is great for things like this. Okay, and so that's our definitions and how just some of our introductory stuff comes about. So now if we go and in the next video take a look at example 2.1, I'm going to show you how in Excel you can do some of these things. How we can do some counts, how we can do some percentages, how we can put together a couple basic graphs.